Okay, so we have page 2. The problem is ethanol, C2H5OH. Any thoughts on why they didn't excuse me. Any thoughts why they didn't combine the H's here to make it H6? Yeah, James.
Last H is connected to the oxygen.
Yeah, good. They're giving you a hint here. They're saying that the O and the H are going to be connected later on. All right, great. By looking at this, what do you think the central atom is going to be? The carbon, right? Because it has the most spots for single bonds. All right, and there's 2 of them. So we're going to assume that they're going to be connected together, right? And then what else is probably going to be connected to the carbon? Yeah, the oxygen. So we'll just put that somewhere as well. Okay. All right, so we just connected that as well. We have 6 dots around the oxygen, bonded it up. If we count around here, we have 1, 2, 3, 4, 5, 6. We have 5 and 6. So then we just put them in, and we'll get our molecule. Okay, so we get this. We need to check the shape of this to make sure that everything's good. So carbon, that's going to be a central atom. So let's look at that one. What's the AXE for this one? Good, yeah, it's AX4. All right, so we have that, right? This carbon's connected to 4 other things, so AX4. What's the shape for that? Good, tetrahedral. All right, and the angle? Good, 109.5 degrees. All right, hybridization? sp3. Whenever you have tetrahedral, you're going to think sp3. Good. All right. Anything else we can figure out for this one right now? That's pretty good. What do you got, Haley? No? Okay. All right, so this one, same thing, right? This is going to also be tetrahedral because it's AX4. And then here we have, what's the oxygen going to be over here? Good, yeah, we're going to have AX2, and then there's 2 pairs of electrons, so it's going to be E2. What's the shape for this one? Bent, good. Okay, and the angle? 104.5. Good, 104.5. All right, and then SP, what? Nothing. It doesn't work for hybridization, right? All right, great. Okay, so did we draw this correctly as a bent? Looks pretty good, right? Okay, so let's redraw this kind of as our final draft. Okay, and now we have to look at polarity, right? So what's carbon's number? If you look on your chart, it should be 2.5. And then what's the hydrogen? 2.1, okay. So we have all these 2.1s going into 2.5s, but if you look at this left half of the molecule here, what do you notice about it? It's a hydrocarbon. What do we know about all hydrocarbons? Yeah, they're gonna be nonpolar, right? So all of these 0.1s are gonna cancel out with the other 0.1s and whatnot. The only part that's different in this whole molecule is the oxygen here, right? And if you see an oxygen, you should think, okay, it could potentially be polar. We just have to check things out. So what's oxygen's number? 3 point what? All right, 3.5. All right. So going from the carbon to the oxygen, we have it going 1.0. And then going from the hydrogen to the oxygen here, we have 1.4. All right. So we have a lot going to this oxygen, and it's kind of off on its own. It's off on the side here. So whenever you have something like that, this side of the molecule will be the slightly negative part because it's more than 0.4, all right, so it's in that polar range. And then this side of it's going to be slightly positive, all right, and especially this little H over here, all right. So that's where you would get most of your charges, all right. Does that make sense? All right. Harris, you good with that? Okay. Alright, so like the cutting it in half would be like the oxygen part, and I know it's not a straight line, but it's really gonna be, that's gonna be the negative part, and then this is gonna be positive, and this is gonna be pretty non-polar, but still, it's gonna be a little positive, alright? Okay.